All right, students. So welcome to the day 8 of our rapid revision session for the 2026 A-level students. All right. So today we'll be discussing regarding the full ladder and the full ladder from the half adders, right? Full ladder from half adders. So now, last time we discussed about the full ladder, half adder, and then the flip-flop as well. So you all can check back the last session. So I have given a very good idea regarding these full ladders and half ladders. So there is another part where we can draw the full ladder from half ladder. So what I'm going to do is, first of all, I'll just sketch down the full ladder and the half ladder. So yeah, I'll draw the full ladder. A, B, C. I'm not going to explain the full ladder in this particular session. If you want, y'all can watch the previous session. So this is what the sum looks like, which is A, B, and C. Then so this is what the carry bit looks like, the extra bit which we are taking forward. So AB plus AC plus BC. So this is what the full ladder looks like. So let me draw the half ladder as well. So when it comes to the half ladder, we got the same A and B. Only two inputs are there. This goes through an XOR gate, which is A XOR B. That is the sum. Then once again, it goes through an AND gate, which is the carry bit, which is A dot B. So what I'm going to do is I'm going to draw the full ladder using the half ladder. And also this is also a theoretical part, students. You all don't have to by heart the whole thing, right? This is a theoretical part, right? Okay. Now, first thing is I'm going to start with the C on the top and A and B are there. So what is happening is, so C is there, and then A and B, it goes through an OR gate, and once again this goes through another OR gate. Now this one looks like A B C. All right. Now there is an AND gate in here as well, which is supposed to take in A and B. So this looks like A dot B. So we got this one done, right? A dot B is done, and this particular part is also done. This is done. This part is also created. Now what we are supposed to do is take this and also apart from C, right? And go through another AND gate, right? Now, all right, this is there, and then these two are going through an OR gate. All right, so let me, so this is done. So let me mark it, right? So this particular part is one half adder, and this one is another half adder, right? It's the same thing. So I'm using two half adders in this case. Uh, now let's see this particular output first. Now we got this one correct, right? It's okay, right? So A, B goes through. So this one is A, B XOR B. So it goes through this one, and again C is getting joined. So the sum is okay. But then there is a bit of a confusion when it comes to the carry bit, right? So $8 mark B, no, so not dollar mark, A XOR B. So this is A XOR B. And then C is also coming. All right. So this one. So finally we have A XOR B, C, and then plus A dot B. Now this is bit of a problem. Now this is not what we were expecting, right? This is not the answer. So we have to simplify this. All right. So we are having a bit of a space in here, right? So I'll simplify it in here then. So A XOR B C plus A dot B, right? Now A XOR B, we can simplify it as A dot B bar plus A bar dot B, right? We already learned that in the previous lesson. So this one, I drew a Kano map also and showed you all. So we can draw it like this. Then A dot B bar C plus A bar B C plus AB. Now, it is not simplified, right? So A B bar C plus, I'm going to take B out. B is common in here. So wait, let me write it once again. Remove the brackets. We don't need the brackets now. So A, B bar C, I'm going to take B out. And then we got AB plus A. Now this is equal to the redundancy law, which is A plus B, right? AB plus B. Okay, we made a mistake here. Okay, this should be C, students. I made a mistake at that point. So C, it's not B. So A, B, and B, C. All right. So once again, I'm gonna take A out. So inside we got B, C plus B. So this one, once again, it's equal to B plus C. That is the redundancy law. That is the redundancy law. Now, AB plus AC plus BC, right? We got the same exact answer which is coming to this particular full ladder, right? So even though we got the carry bit in this way, so this is the carry bit. So even though we got it like that, we can simplify it and get the same answer. So if they ask y'all to, once again, this is a theoretical part, right? So remember this one, you all have to practice this, because at the exam, students, there's no point of like thinking about it and answering it. It would take a lot of time. It would waste your time, right? So it would waste your time. So therefore, you should by heart this one, practice it a couple of times. Okay. So if they ask you all to do this, you should be able to like quickly do that question. And most of the time, students, what I have seen is in the recent exams, okay, in the recent exams, they don't give you all much time to answer this particular one, right? This is most of the time, this is at the end of the page, end of the question. This is the last question. And since this is a theoretical part, they expect y'all to do this in a few minutes, because they have asked a lot of like Boolean questions, Kano map questions. Thinking part is on the top, and the bottom part as a theoretical question, they're only asking this particular question. So they expect y'all to, get the answer quickly and write down the answer quickly, right? So you should by heart this one, and the previous session as well, the full ladder, half ladder, and the flip-flop part, that is also a theoretical one, right? All right, so I'll wrap up this session. So this was a very small session, right? So y'all can check the other sessions as well. So each day a video will be uploaded, and there is a plan. I have already made the plan, but if y'all need me to, do anything extra, if you all have any suggestions, y'all can, mention it in the comments, and also share the video with your friends as well. So it's, completely free. It's on YouTube. So all right. So let's meet in the next session.